Okay, in this video, we're going to talk about our next reaction, which is a single replacement. Our big idea from today's lesson is that by knowing our reactants, we can actually predict the products for different types of chemical reactions. So we're looking at a single replacement. So when we think of single, no, not you on a Friday night. Okay, just kidding. Single just means one. So we're going to be having one replace with a couple that we have here. So this is our scandalous reaction because we have an A by itself, we have our BC couple, and then we'll notice that our A has now replaced our B to be with C, and then B is by itself. So we call this a single replacement because we just see one replacing another. So if we look at our example of this meme, we would see that our C is by itself, and then we have our A and B, and this guy is eventually probably going to be with our C, leaving our A by ourselves. So who knew this meme could be scientific too? So let's review the different types that we've been working on before we dive deeper into our single replacement. So remember, we have our first one we looked at was our synthesis. Our synthesis was two coming together. We had our decomposition, which was two breaking down. We had our combustion, which means that we needed our hydrocarbon with our fuel of oxygen forming CO2 and water. And then now this single replacement. So every capital letter, or AKA atom, is going to have an A, B, or C to it. So if we look at the first one, Mg is my A, Ag is my B, and Cl is my C. So now notice that our A is with our C, and we have B. So we have a one switch there, aka a single replacement. Now number two, our N is our A, our H is our B, and notice that they have now separated out. So if they're breaking down, that's going to be a decomposition. Number three, we have our A plus our B now came together like a marriage is going to be synthesis. We have Cl2 is my A, K is my B, Br is my C. So now K, B is with the A, and C is on its own. So that's going to be a single replacement. And then our final example, Na is my A, Cl is my B, and then they came together just like number three for a synthesis. Now notice that there were no combustion reactions in this. If we did have one, it would be our hydrocarbon plus our fuel yields CO2 and water as its products. They can be interchangeable for what we have too. Now, how do we know in the single replacement if they're going to be enough to replace the metal it's working with? So how do we know? We'll see that a higher metal will actually replace a lower one, and we have a hierarchy of our list. We have our most reactive metal as Li on the top, and our least is gold. And that makes sense because we wouldn't want to wear gold or silver jewelry and have it reacting on our skin with water or any of these other parts. So that's good that it is the least reactive. And what this table means is that you can have K replace anything below it, but K couldn't go up and replace Li. We can have Fe in the middle, can replace anything below it, but it could not go up and replace anything above it. So a higher can replace a lower, but a lower cannot replace a higher. So let's decide what's happening with these reactions and if they would occur. So notice that I highlighted it to make it a little bit easier to see. So we're asking ourselves, would Ca be able to replace Cu? So we're going to find Ca. Right here, we find Cu down at the bottom. So can Ca go down and replace Cu? That would be a yes. Okay, our next one, we're going to see Zn and Li. So we find Zn, we find a Li. Can it go up and replace? No, so that reaction would not happen because Zn is not as reactive as Li for it. Okay, so our next one, let's take a look, is going to be Ag and CO. So we find Ag here, we find CO here. Can Ag go up and replace it? This would also be a no for it. So remember, a higher can replace a lower, but a lower can't replace a higher for it. So you can watch the link for the single replacement demo And what we're looking at is taking zinc, adding it to hydrochloric acid, and forming solid zinc chloride and hydrogen gas, which is highly flammable. So what we see in these balloons is that hydrogen gas, which is highly flammable for it. So let's balance it and see if it would happen. So we have Zn, we have H, we have Cl, we have Zn, H, and Cl, and then we made our list, so we're gonna decide how many we have. We have 1, 1, and 1. We have 1, 2, and 2. So how do we make a 1 look like a 2 on this side? We're gonna place a 2, and that actually made it balanced for both of these. So then notice that we have 5 atoms on both sides, and we are balanced. We can put 1s here if we'd like for it. Now the question is, can Zn replace H? So if we go back to our hierarchy, and we find Zn right here, we'll find H down here. So can Zn go down and replace it? Yes. So this reaction would happen. This image kind of gave you the hint that it would happen for it. So let's try a lesson check before we leave for today's video. So can potassium K replace silver? So number 1, we find K, we find silver. Can K go down and replace? That would be a yes. Okay, cobalt is CO replacing lead, which is Pb. So we have CO, we have Pb. Can it go down and replace? That is a yes. Okay, our next one, aluminum Al replacing calcium, which is Ca. So we have Al, we have Ca. Can aluminum go up and replace? That would be a no. Okay, last one, we have iron, which is Fe, and we have magnesium. So can Fe go up and replace magnesium? That is also a no. So remember, a lower cannot replace a higher. A more reactive can go down and replace a least reactive. Now 5 and 6, we're going to actually be predicting the products. So first you have to ask yourself, can it do the replacing? So can K replace Ag? So we found K at the top all the way here, and we find Ag at the bottom. So can K go down? Yes, that was number 1. So this reaction would occur. So if K is A, Ag is B, and Cl is C, my apologies, we're going to see that A is now going to be with C and B is by itself. So now Ag is by itself as B, and we're going to see K is with Cl. Okay, now our next one. Can Cd replace Ni? So I'm going to change my color for it. We're going to see Cd is right here, and we're going to see nickels right here. So can Cd go down and replace? Why, yes, it can. So Cd was my A, nickel was my B, and NO3 group was my C. So I'm going to see that my A and C are together, and my B is by itself. So nickel is by itself, and we would see that it would be CdNO3 and then a little 2. If you didn't have the little 2, that's okay. We just know because Cd always has a +2 charge for it. So hopefully this helped looking at the hierarchy of the metal activity series on whether it will replace another metal and then predicting products in number 5 and 6. So thanks for watching.